A very good afternoon to everyone. SC Engineering College is a distinguished institution with a legacy of 26 years of excellence and in education. It is an autonomous institution affiliated with Anna University, a prestigious technical university in India. The college has earned accreditation from NAC and NBA, highlighting its commitment to qualify education and continuous improvement. SC Engineering College offers a diverse range of programs, including 11 undergraduate courses and 6 postgraduate courses. The institution is known for its academic accuracy, innovative teaching methodology, and holistic development. It is with great pleasure that I welcome Mr. Navanitha Krishnan Ramanathan Sir to our event Tech Series 4.8 organized by CSC Artificial Intelligence and Machine Learning Department. Mr. Navanitha Krishnan Sir is an individual of remarkable versatility, blending entrepreneurship, academia, research, and leadership across multiple domains. As an accomplished entrepreneur, Mr. Navanitha Krishnan Sir has demonstrated his progress in establishing leading virtues, notably as a director of global partnership and government relations at MetaSearch Alliance and director of iExplore Foundation for Sustainable Development. His contribution extends beyond business as he has also been a key figure in academia, mentoring students and professionals in the realm of recurring innovation and entrepreneurship. Mr. Navanitha Krishnan Sir commitment to research is evident through his impressive publication record with over 30 articles in reputed journals and conferences, along with his pursuit of patents to further advance technological frontiers. His development with IEEE holding positions such as chairman of the IEEE Society on Social Implication of Technology and executive committee member of the IEEE Robotics and Automation Society showcases his dedication to advancing technology for societal benefit. His contribution to IEEE Foundation and IEEE site funded projects worth $3 lakh underscore his commitment to technological advancement and social impact. Furthermore, his editorial role as the editor-in-chief of the International Journal of Innovative Science and Applied Engineering Research showcases his dedication to scholarly pursuits. His recognition by Niti Aayog as one of the top 37 mentors in India underscores his impact and influence in shaping the next generation of innovators and entrepreneurs. Mr. Navanitha Krishnan Sir experience as a core team leader and single point of contact for the Robert Roch Center for Excellence for Automotive Electronics highlights his expertise in cutting edge technologies, particularly in the realm of electric vehicles. Today, we are privileged to have Mr. Navanitha Krishnan Sir share his insights on AI for electric vehicles, a topic of immense relevance and significance in our rapidly evolving technological landscape. His expertise and experience make him a valuable resource for understanding the intersection of artificial intelligence and sustainable mobility. Without further ado, let us welcome to Navanitha Krishnan Sir and eagerly anticipate the enlightening disclosure as he is about to deliver. Please, sir.
Thank you. Uh, Good afternoon to all the participants joined here and also through the YouTube. First, I would like to thank a good friend, Dr. Kotishwaran, head of the department CSE Artificial Intelligence and Machine Learning, and the coordinator, Dr. Praveena, and the whole team, AIML CSE department from SA Engineering College for hosting me in this program. So SA Engineering College to me is known for vibrant IEEE student branch engaging in various activities, molding the students to go global through various forums. One such is IEEE. Many of the IEEE volunteers who worked with me in the past came from SA Engineering College. I got introduced to SA Engineering College through one of your alumni who worked with me in IEEE, successfully in various other events. That way, I have a lot of respect, and I have seen a lot of things happening from SC Engineering College. So I wish this will continue forever to mold the students not only in the syllabic part and also the holistic development, as somebody introduced. The holistic development is very important, and to have the holistic development, not just an syllabic content, won't suffice. So best wishes, and hearty congratulations to all the host and IEEE student branch members. They are doing a lot of wonderful activities, which is getting known to the even IEEE headquarters. Let me share my presentation. So I'm not going to limit in today's session only with the electric vehicle, but also AI. Today, AI is everywhere. You know, now you cannot find any person who has not used the chat GPT or any of the AI tools. So AI is embedded into in all of our lives in day-to-day lives. So I'll in this session I'll touch upon the impact of AI in making any automotive or any vehicle into smart vehicle, be it an electric vehicle or any vehicle. I'll start this session with this very powerful and impactful quote that I like the most by Henry Ford. Basically, simple things are really best anyways. Whenever whether it is automobile or diet or anything, things which has the simplicity. To quote another example, when the mobile phone industry was having mobile phones with n number of keypads, like in olden days people used to have the mobile phones with QWERTY keypads. Though the keypads what we have in our computer, we used to have in the mobile phone in those days. At that time, the Apple came up with an idea of having only one keypad, only one button in the mobile phone, which is very very simple and which disrupted the market. And still, we use the same kind of environment. Now you cannot see any mobile phone with QWERTY keypads, right? So ultimately, the simplicity is an ultimate sophistication. That is what the Henry Ford or Steve Jobs or whomsoever was doing a great innovation in the industry are doing or following. So I'll try to keep this presentation as simple as possible. Let us look at the evolution of how the transportation, the past, present, and the future. In those days, people used to lift people for transportation using palanquins, and people used the carts or horse. And then the invention came, people used the bicycle. And Carl Benz is the guy, is the one who invented the automobile, and this was his first patented, model, the world's first automobile in 1886. If you look at this closely, it is purely a mechanical element. It is purely something which is made up of steel and metals, which has an engine, which is an again a mechanical thing. You cannot even see any trace of electric involved in this, except something used for sparking. Even that was not too much in those days. It was a completely a mechanical device or a mechanical machine. When it comes to an evolution, the vintage cars era, if you look at the vintage cars era, very minimal electrification gone into an automobile, like for headlamps or starters, electric starters. Even in some of the vintage cars, even you can't find the starter, a motor to start. A self motor you can't find. One has to have a handle, and you have to rotate to give a rotation to the engine to get it started. Very very minimal traces of electrifications found in the vintage cars era, that too for very ultimate purposes. So in those times, the basic parts of any automobile were basic structure that will have all base, the wheel, axle, and the suspension and the chassis, the frame on which the whole vehicle to be built on, and the power unit. which is basically an engine to produce a power, which involves the fuel system, carburetor, ignition system, exhaust system, and cooling system to cool down the engine. And transmission, whatsoever the power gets generated from the engine, has to be driven to the wheels, and the transmission system helped the automobile to pass on the energy or the power created in the engine to the wheels. Control systems obviously to control the dynamics or movement of the vehicle, and some of the very basic kind of headlamps kind of thing and the body. This was a basic part of automobile in those times. In mid-age cars era, some more electrification in terms of indication lamps inside the car, and infotainment systems like music player, things like that came into an existence, and cars got little bit electrified. In a modern car, be it an car which runs on a fuel, petrol or a diesel, we call it as IC engine, internal combustion engine. Even those IC engine cars are completely controlled by an electronic control units, be it an engine or a braking system or an infotainment system or a door control system. You name any component, any component in a vehicle, completely controlled by electronic controls. This is in a modern car era. You can see a basic example for the electronic, one of the ECU, most popular ECU is engine control unit. In those days, in those times, in the mid-age cars or in the vintage cars, we use the mechanical elements to control all these things. Say if it is accelerator, there will be a cable or a lever attached to the accelerator pedal. When the accelerator pedal gets pressed, it will give a pressure through a lever or a cable to a carburetor or to a fuel system to adjust the speed of the vehicle. But in the modern cars era, this engine control system has a sensor attached to the accelerator pedal, and it senses how much pressure is applied on the accelerator pedal and sends the signal to the diesel engine management system if it is a diesel engine. Depends upon this signal, the engine management system gives an indication to a signal to the fuel injector in such a way that based on the pressure applied, the fuel will get injected so that the car will go fast or go slow. This is quite common in all the modules of an automobile. Say some other important electronic control units in any of the automobile or fuel system, braking system, ABS, EBD, many other advanced systems are there. Steering system, again today the steering system has got completely electrified. It's more like your joystick what you have in your video games. It's or sometimes it's electrically assisted power steering. You need not to put your full energy to rotate the steering wheels. It's completely electronic, just that. And safety systems, very important aspects today. Even the very basic, it has become a very basic hygiene of any cars. It is very very important for any automobile, the safety systems like SRS airbag and many other systems, preventive and predictive safety systems. Navigation and infotainment systems, obviously completely electronic driven. Battery management system, park assistance. I can talk on any number of electronic control units in the modern cars. At some point in time, these IC engines cars has got the saturation where the energy efficiency and pollution came into the picture. Even in India, in most of the cities, say Chennai or at the peak in Delhi, the pollution is a very important problem. You might have heard in the news channels during the very cold winter times, the pollution goes really high, so that the government of Delhi has announced or put a policy guideline that on a day, say if Monday only odd number of the registration, they used to see the registration numbers. Only odd number registration cars has to go on Mondays, and even number registration cars has to go on Tuesdays. Like that, they have planned many things. It was the very big problem. This is happening all over the world. To mitigate that, the also the energy, the the petrols and diesels what we use are from, again, non-renewable resources. So the world is going towards how to save these non-renewable resources and go for renewable resources, right? So in that crisis, that emergence came for this electric cars. Now you can see electric cars or electric scooters running even in your neighborhoods, just like that. Even in a minute, you can spot at least one or two electric vehicles, be it a car or a scooter. It is growing. The electric vehicle market is exponentially growing than it was ever expected. If you want me to say what is there inside in an electric vehicle on a nutshell, electric vehicle runs on a battery. We need not to put any fuel. There are some hybrid cars. Say today also we have hybrid cars, which runs both on fuel and also electricity. Inside, it is so the actual to a hybrid mechanism. Say I have, just 2 weeks back, my one of my friend bought a car, just I think high cross in Toyota. It runs on both petrol and electricity. First, till 20 kilometer per hour, it goes in a motor. It goes as an electric vehicle. After that, it runs on a fuel. Like that, the hybrid cars are also there. But the electric cars purely runs on battery. So it will have a battery charger through which we used to give an energy, and it will have a high voltage battery. If you see, most of the weight of any electric vehicle goes for a high battery pack. There are a very big research is happening across the world to reduce the size of the battery and to reduce the charging time of the battery. Today, we need minimum 30 minutes to 1 hour to charge the battery, and people are working to reduce it further. The battery, all we all know, the battery can hold the charge, hold the supply, and it will be in a DC form, right? And then when we want to move it to the wheels, ultimately the car runs on motors. The motors helps the wheels to run. The motors are AC, so we used to have a inverter to change this DC to AC, and other DC loads are also will be there. Some of the infotainment systems and many things will run on directly DC, where we need to step down or step up the voltage. All these conversion, inversion, all the mechanisms will be done inside the car with appropriate units, and ultimately it will run on an electric charge. So as I told, the energy efficiency is an ultimate thing in having these many number of electric vehicles and electric cars. Now we have got the electric car somehow, and now the world is moving towards self-driving and autonomous driving. Even in the countries like USA, especially the Silicon Valley, California, the electric cars are running on roads like how we have the self-driving cars, autonomous cars are running in the roads, as like how we have electric cars today we have in India. So physical, basically, if you want to say what is there inside an autonomous car, you might have seen in the videos. If not in real, you might have seen the Google autonomous car or any car. It used to have a lidar unit. Some are attached with lidar, some are attached with lidar directly on top of the car, some are in different positions. It will have both the lidar and also the camera, which will act as an eye of that car, which will see the surrounding and gives an input to the computer. You can see a computer sitting inside the car, which processes the data captured by the cameras and the lidar unit, and identifies whether is there any obstacle or the way the car is traveling is correct, all those things, and gives an important information or a signal to the wheels. Based on that, it will run. It will have multiple radar, uh, sensors, also the radar sensors in back and front, and also the camera. So, where the automobile industry is looking for, where they believe they are in, and where they want to go ahead, they feel electrification, automation, and connection is the way forward. Now, the electrification is almost done. This getting done in a faster phase. The connection on automation is what something the industry is expecting. Be it any type of vehicle, it is getting electrified. That is evident today. You can see both your scooters or load vehicles, or domestic vehicles which are used in inside the parks. Say you might have seen buggy cabs going inside the campuses, things like that. It is similar for the outside commercial vehicles or other vehicles also. In cities like even in Chennai, you can able to see many buses running in electric buses. It's going to be quite common to have electric cars or electric buses all around very soon. Next is connection and automation. Automation is what it is expected. There are five levels of autonomy. There are five levels in automation. The level one is just a little bit assistance to the driver. It is called driver assistance systems. In level one, the driver has to be there inside the car. It is not an autonomous. It will help the driver to go to relax something. Say there is adaptive cruise control. If you set up the adaptive cruise control in 100 meter per hour speed, you need not to present the driver need not to press an accelerator. It will go in an 100 kilometer per hour speed. If it finds any obstacle, the car itself will slow down. And there is a lane keeping system. If you set up in a highway, if you turn on the lane keeping system, and if you turn on the accelerator, adaptive cruise control, and set a speed of 80 kilometer per hour, the adaptive cruise control will take care of the speed of the vehicle. The lane keeping will take care of the steering system. It will go on a road. The driver need not to worry about the steering part. So basically it's but for that matter, it doesn't mean that we need not to have a driver inside. It will assist the driver. Also emergency parking, as I told, braking. If you set 80 kilometer per hour in an adaptive cruise control, if it finds something in the road, if it finds some obstacle, or if it finds some vehicle is going in front of our vehicle, it gets slowed down. Then based on that, it will also get slowed down. And parallel park, all of these very minimal assistance systems comes in level 1. Level 2 is partial automation. It will give a relaxation to the driver, feet level relaxation to the driver, you can say. Driver, a little bit have a relax in his feet, like accelerator, adaptive cruise control with see the steering and lane changing. If you set up a lane changing, even if the vehicle finds something going very slow in front of him, some other vehicle, and if it will automatically find is there any other lane, and it will change the lane, go beyond that vehicle, and again change the lane to the original position, like that. Overtaking assist, all these things comes in level 2. So basically level 1 and level 2 are advanced driver assistance systems, which will ultimately assist the driver. In level 3, the driver can give some relaxation to his hand also. Some more advanced level of conditional automation will happen. Driver initiated lane change, automated valet parking. Say in a sophisticated environment, the driver can go and put at autopilot mode for a parking. Autopilot parking mode, it will, if that infrastructure, if that building or that parking has that kind of infrastructure to get the vehicle connected and to assist the vehicle for an autonomous mode, it will go and park. In level 4, high level of automation, but still the driver is needed. It is eyes on. The driver can be simply there to take the control of vehicle if something goes wrong. In level 4, the level 5 is, what is expected to be the full automation. The driver itself need not be there. You can we need not to have drivers in the cars. You can simply get in and set up your destination. It will go. It is expected to, the world is expecting this to happen in 2017. The research for this level 5 of automation is extensively going on. And as I told, we are in level 4. You can see many vehicles, even in USA, you can see many autonomous vehicles, going here and there. Even in India, it's in the testing phase, right? The level 5 in a research level, and on a road level, it is somehow achieved. It's going well. But in India, the infrastructure is the very big problem. It is not very easy to have automation, autonomous operations with this kind of this thing. Many researches are happening. Even 2 weeks back, a startup from IIT Madras have developed an autonomous system, and they installed this autonomous driving system in one of the Bolero cars. You might have seen in the social media; it went viral. It's happening, right? So level 5 is the complete autonomy. All right. So I think I will skip this slides because this is not an interactive session. So the point I'm coming to say is, today the whole world is talking about UN Sustainable Development Goals. There is a strong relevance for the world to move towards electric and autonomous vehicle for the UN Sustainable Development Goals. Yes. UN SDG is established by the United Nations for all the participating countries. Whoever comes under United Nations, or those countries are making their policies to achieve these UN Sustainable Development Goals in 2035. It covers all the growth verticals of the country, say no poverty, zero hunger, like that. And for this electric vehicles or smart vehicles to happen, you can see industry, innovation, and infrastructure. Under that, all these things are happening. Also, life on the water. This electric vehicles pollutes less than the IC engine cars, things like that. And UN Sustainable Development Goals is the talk of the town everywhere. My recommendation to you is, just explore about this UN Sustainable Development Goals, what is happening around this UN SDG, and what it is all about. Try to pick some of the favorite goals, which makes you interested, and explore more, and try to add some value as a student. You can do some project which will address some of the issue which contributes any of these sustainable development goals. That is my recommendation at this point. Coming back to this topic, smart vehicles, that is where the world is going ahead. For this smart vehicle or any autonomous vehicle, autonomous operation to happen, this powerful combo is very, very important: AI and IoT. You might have seen these terms AI and IoT are used anywhere and everywhere in today's world. You say any gadget or any device, it is embedded with IoT, it is with AI. So if you want me to say the difference between AI and IoT, yes, if you want somebody to be very smart, or if you call somebody as a smart guy, then he should have that kind of efficient decision making power to make the decisions, or to do something. To In order for his mind to think, he needs some data. Based on the surroundings, based on his past experience, he will decide, and he will do the things. If you imagine the same situation for the smart vehicles, the AI is something which makes the vehicle to think wiser. For that, to make the smart decisions, to make the wise decisions, it needs a data. For that, how we get a data? By seeing, by hearing, by feeling, right? We have our peripheries, we have our things. Similarly, the IoT elements are the sensing devices. It will have a lot of sensors and devices which will get the data from the surroundings, from the zone, or from the environment, and it will give a right and necessary data to the brain, which is a processor. The AI algorithms sitting over there will use those data and make an efficient and smart decisions, so that for any autonomous or smart operations to happen. That is what happening in this automotives as well. In the upcoming slides, I'll be taking you through some of the important applications which are driven by this powerful combo AI and IoT, which exist in the smart or autonomous vehicles. You need not to think whether it is a electric car or an IC engine car. The smart systems, couple of the smart systems like advanced driver assistance systems are also there in IC engines. But when you want me to talk about the role of electric cars in autonomous or smart vehicles, the electric cars are preferable choice for autonomous or smart vehicles because of the reason the controllability of the vehicle. Say if the car is running, moving the car and reducing the speed and stopping the car is so very easy in electric vehicles because it is completely controlled by electric, you know things, electronic control units, and the power generation itself gets done using motors. Whereas in the case of IC engine, it's little difficult to control. So you know that is one reason. Another reason, now the whole world is moving towards electric vehicles. So for the smart or for the autonomous vehicle, the preferable choice is electric vehicles. But there are few AI enabled smart features found in IC engine cars also in today whatever you can see in high end cars. So as I told, the advanced driver assistance system will ultimately supports or eases the job of the driver. It will sit on level 1 and level 2 of autonomy. It won't go beyond. Say it will assist the driver to do his job, which is primarily driving in an easy way and in a safe way. Fleet management system is one of the application which involves IoT, more of IoT and less of AI. So with this fleet management system, say you might have seen Ola, Uber, things like that, how it is functioning. Without AI and IoT, you cannot imagine Ola or Uber. Starting from where is that car? What is the traffic condition in that area? Whether that car is in a running state or not. Whether that car can able to reach this customer on time or not. Whether the customer can book that car or not. Everything goes through AI. You might have seen this app where it will show once, for the same location, if you want to travel to the same destination from your home, you might have seen the differences in fares. Sometimes you might have been charged 150 rupees, sometimes 500 rupees. There are multiple factors involved in it. Depends on the traffic, depends upon the demand, all these decisions are done using the AI. So this fleet management system for any company, for anybody who has multiple vehicles, they can have this fleet management system, which helps them to strategize how good the car is, when the service due is for this car, the fleet strategy, the fleet wellness, and its administration. When we can use this car, and when can we dispose this car? What is the say? This car we have used for 2 lakhs kilometer in the past 5 years. Can I continue using this car, or is this the right time to change the car? All these things can be done using this AI. The decisions can be made using this AI. So end to end, fleet strategy, fleet acquisition, fleet services, maintenance. What is the current status? When I have done a service, when the engine overhauling was done, when the tires were changed, what is the current status, everything, energy management, how much energy, if it is an uh, fuel car IC engine, then how much petrol it consumed. If it is an EV, how much charge till now we have given, risk management, and many other things that we can do with this AI enabled tools. Predictive maintenance, as I told, very very important. In many times, if we can able to predict something which is going to happen, we can avoid the very incurrence of very high costs. Say earlier in those days, all those drivers, humans, they used to see based on the sound of the vehicle, based on the sound coming from the engine, based on the smell coming from the exhaust. They used to say this problem is going to happen, the engine is going to cease, so we need to you know uh, make a top up oil top up, engine oil top up we need to do, or something like that. Today people are so busy and we don't have time, and in this traffic, remember, imagine Chennai, this traffic, it is very very difficult to see all these things. Also today we are not at all even opening the window glasses, so it is very difficult to predict what is going to happen for my car. Now we have AI enabled system which will do what the drivers were doing in those times. It is collecting the data, it is collecting the critical data and process it, and it intimates that the car engine is going to be seized if it goes like this, or it is going to stuck in that way. Like that, the predictive maintenance, which will be very very important. If you think about the company having thousand number of cars, it's very useful for them. Battery management system. Today when we talk about the electric vehicles, battery, how efficiently we are managing the battery, how efficiently we are charging and utilizing the battery power is very very important. And there is a very big research happening over this battery management system. This AI enabled systems will help the car to utilize the battery efficiently, both the charging and discharging pattern. Diagnostics and prognostics. Yes. So you can see today in smart and autonomous vehicles, you can see you will have an app. You can see what is the engine parameter, what is the health parameters of a car. If it is an electric car, what is the parameter? How much charge you have in the car, how much kilometer it will go. Is there any fault in any of the electric, either sensors or the motor or any applications in that? All these things we can have in our mobile app, which is again AI and IoT enabled. To have things automated, the connection is very very important. The cars should communicate with other cars either, or other devices or the infrastructures. Say if it is an autonomous car, you want to go and cross the signal in an autonomous car. If it is a driver driven car, then driver will see what is the signal position in the traffic signal, and if it is a red he will stop, if it is a green he will go. If it is an autonomous car, there are two ways. One is it will have a camera and it will sense, like how the driver see through his eyes. The car will see through its camera and detect whether it is a green or a red or yellow. But what if the camera detects any other red signal, though the traffic signal is showing a green, it detects a red light from somewhere else nearby. Say nearby building is flashing a red light. If it detects that, and car will not go because it will be thinking it's a red signal. And if the signal is showing red, and if it detects some green signal from any of the nearby surrounding, it will start moving. So to avoid these things, we can have another strategy. The car can communicate through wireless medium to the signal post. It need not to see through his camera whether the red light is happening or the green light is happening. It can have a communication when it needs to stop, when it needs to go. So for that, we need a connection. For this connection management, the AI plays a very important role when the connection should get established, right? And it should communicate with the other vehicles. Say in the next example, relative braking system is one such example. If a car is, if two cars are going, a car is going in front of me, is slowing down. Instead of detecting its speed through a sensor, it can establish a communication And when the car once starts slowing down, it will send an intimation to the car too, so that it will also gradually slows down, or it will take another path, a lane changing. All these things will happen when the relative braking system gets initiated. Again, say you are starting from point A and you need to cross three signals to reach point B. If it is a manual driven car, the driver will go in whatever speed he wants. In an autonomous car, the car can efficiently plan a speed of this whole journey, considering the signal positions of signal 1, signal 2, and signal 3. As I told, the cars can able to connect with those signals. Say signal 1 is I plus 1, I plus 2, signal 1, 2, 3. So based on these positions, when the signal 1 will be in green, when the signal 2 will be in green, when the signal 3 will be in green. In what speed if I go, I need not to stop in either signal 1 or signal 2 or signal 3, so that I'll go faster, also I will save my energy. These kind of calculations can happen through AI algorithms, and the car will set a speed in such a way that it will not stop anywhere, and it will go, it will reach faster, earlier, and it will ultimately save some of the fuel, some of the energy also. These are all the some of the aspects that we can see in the cars. And today, some you might have seen the videos of Tesla, very famous autonomous cars, which is running just like that in USA. Again, very important aspect is to identify and recognize the objects, what is in front of me, what is in my surroundings, whether it is a building, or whether it is a car moving towards me, whether it is a person approaching towards the car, whether it is a person crossing the road, or animal crossing the road, or a child crossing the road, based on the characteristics, based on the object. And each and every object will have a characteristic. Say, if hope you might have experienced this, if you if a driver sees a dog crossing the road, he will try to reduce the speed, because it has a characteristic. It will anytime it will come in. You cannot predict. Similarly, the vehicle also has to be very intelligent in identifying the object, and also based on that identification, if there is a dog, the speed has to be reduced. If something approaching to the car, then anytime it may get collided. So what is the preventive action that the car is going to take? All these things involves high level of AI algorithms processing on the vehicle. So again, the companies are envisioning, currently the companies are putting the resources in the car to process all these things. Also, they are envisioning to have the cloud-based processing. The car will only sense the parameters and sends to the cloud space. The decisions will be made in the cloud space. The processing will happen in the cloud space, and it will push the data again back to the car. It will all happen in a micro and nanoseconds. Otherwise, in a moment time, everything will go wrong. So the companies are working on putting all these things in cloud processing, and the cars only will have sensors and actuators. It will sense, send it to cloud, make decision, get the decision, process it. That's what happening going to happen. So finally, this is one of the project that I was associated, when I was in KCT, leading the as a Center for Automotive Electronics with Robert Bosch. We have made this buggy, cab, uh, to work in three modes. One is manual mode, just like that. We have not done anything in manual mode; it will go as it is. Station mode, a person can sit in the station and drive the car, as like how you do the video games. And then autonomous mode, we have done it successfully inside the campus. So from my experience, I have extensively engaged in automotives, working on various companies. So I strongly recommend you, this is a wonderful area for you to explore. And there are lot of opportunities sitting inside, right? So being in AI, you might have also seen this quote: AI is not going to replace anybody. but a person was not who's not using the AI will be replaced by somebody else. So learn to use AI. AI is everywhere. Ultimately, it will also be there in automotives. It has a very big role to play. So you can explore, as I told, you can keep this point and also the something I discussed about the UN Sustainable Development Goals. The recommendation I have given regarding the UN Sustainable Development Goals, you can explore more about these two, and you can try to say how you can add value to the UN Sustainable Development Goals, where you can contribute to which goal you can contribute, and how you can relate this automotives. If you are passionate about automotives, and if you are fascinated about AI, you can mix and match all these things and come up with uh, some projects, right? So when I say project, I'm also part of couple of programs. One is going to happen on 29th of June in Coimbatore, Big Bang. It's a part of Rotary Club's initiative. It's an innovation competition for the school students. If you have any projects, the QR code is here. You can screenshot this page. If you scan this QR code, you will get the link to submit your project. If you have any project, anything, it need not be only the automotive project, it can be anything. You can submit here. If you get shortlisted, you will be called for a final, which is going to happen in 29th. The deadline to submit the project is June 20th. You have enough time. It is going to have exciting cash prizes also. 1 lakh cash prizes is going to be there, and it will be a very good program for you to attend. If you have any projects with you, or if you are planning something, you can submit it. So you can, if you want, you can take a screenshot of it. Another important program, it's a global program. I'm the chair for this program, which is going to happen in Tunisia in September. Now it's the call for projects is open. Again, if you scan this code, you can register yourself and you can submit your project. If you get shortlisted, you will be called for a finale, which is going to happen in 8th and 9th of September in Tunisia. It is an international program. Every year we do this. So these are all the two programs that I wanted to recommend you and refer you. If you are interested, you can register for it. So with this, thank you so much for patient listening. Once again, thank you so much for Dr. Kotishwaran, Dr. Praveena, and the whole AIML CSE SE Engineering College team for this wonderful opportunity. It's always pleasure engaging with you. So looking forward for further engagements. If you want to reach out to me, you can reach me through email or phone. I'm pretty available in WhatsApp, or you can connect me through Facebook or LinkedIn in the name Navneet Krishnan Ramanathan. Thank you so much once again. Bye.
Thank you, sir. Now I'll give my vote of thanks. On behalf of CSC Artificial Intelligence and Machine Learning Department of SC Engineering College, I extend my heartfelt gratitude to Mr. Navanitha Krishnan sir for gracing us with such valuable insights on AI for electric vehicles at the Tech Series 4.8 event. Mr. Navanitha Krishnan sir, expertise and passion for innovation have enlightened us all and provided a deeper understanding of the intersection between AI and sustainable transportation. His contribution to academia, industry, and society are truly inspiring, and we are privileged to have had this opportunity to learn from him. I also want to thank the participants, organizing team, and volunteers who have worked tirelessly to make this event a success. As we conclude this enlightening session, I urge all the participants to share their feedback form through the feedback form provided and will receive the certificates. Once again, thank you to everyone who has contributed to making this event a memorable and enriching experience. Thank you and have a wonderful day ahead.